Hello everyone. Today we're gonna install Gentoo, more specifically a hardened version of Gentoo with Linux installed. For those of you who don't know, Gentoo is a Linux distribution. It's more of an advanced Linux distribution, and mainly it compiles everything from source. So anything you will need to install on your computer, it will need to be compiled on your computer before it is installed. Okay, and that could be beneficial for us because we are able to remove stuff we don't need. For example, we can remove stuff from the kernel. We can select stuff that we don't need, and that way it will be less bloated and more secure. Uh, we're also going to do a full disk encryption. So we're going to use crypt setup, which is a tool that interacts with the dencrypt encryption subsystem in the Linux kernel. So dencrypt is only concerned with the encryption of block devices. Lux is just like a standardized way of formatting a drive for encryption. Also, it's a standard for password management when we're using encryption. So this is how our partitioning scheme will look like. We're gonna have three partitions mainly: a slash boot, swap, and our root partition. Now, our swap and root partition will be encrypted, but our boot partition will not be encrypted. The reason for that is that's the problem with the software encryption. Mainly, you need somewhere that is in plain text or that's like clear, not encrypted, where you can put your mechanism to decrypt the rest of the drive. And we can't do that from the BIOS, so we will need to have our slash boot uh, unencrypted. And recently, there's another way where you can encrypt your boot, but you will need to you put that mechanism in grub, but also it doesn't support loop version 2, which is the new version. So for this, we're gonna go for this. We're gonna just keep slash boot unencrypted, and maybe we can talk about ways to mitigate these kind of attacks. By the way, we call these attacks evil made attacks because, well, evil made attacks are uh, all attacks that are mainly concerned with physical access to a device, which is basically someone that has access to your laptop, and he is able to tamper with your bootloader since it's not encrypted on your drive. He is able to replace, for example, your initramfs, which has the mechanism to unlock our root partition. Uh, he can replace it with a malicious one. Mainly, the malicious one will only be like put the passphrase somewhere on a text file, also under slash boot, and that way the attacker can come back later and he can look for that text file and reveal your password and have access to your computer. Uh, One of the ways to mitigate against this is I've seen people that actually move their bootloader to a USB drive. Uh, they move the bootloader to a USB drive and they keep it with them, like from in a keychain. And anytime they want to boot their computer, they just insert that drive, and you will have to move your slash boot uh, into your root partition, and then you will actually have like a full disk encryption. But it's also very tedious because whenever you have to do upgrades or anything, you will have to have your USB drive plugged into your computer, and also like if you lose that USB, it's gonna be like very hard, even maybe impossible to access your drive again. Okay. Of course, if you move your bootloader to a USB drive, you will have to tell BIOS to only boot from USB. All right. Uh, Concerning the swap, for the swap, we also want that encrypted, because if your RAM is full and you start writing to swap, it will be unencrypted. You will have like an unencrypted part on your hard disk, which is a security risk, because some people, like an attacker, can get clear text information from it. So for that, we also don't want to deal with swap. Like every time we boot, we don't want to just like put a passphrase for it. So for that, we're just gonna say like use a random password every time, and every time we boot our system, our computer, just re-encrypt it all over again. So it will be reinitialized at boot. Okay. The downside of this is we will not be able to have hibernation. The hibernate feature will not be available if we do that, which makes sense. Um, so the second part is, since we're using Gentoo and compiling from source, we're gonna select stuff from the kernel and remove them. Uh, Stuff like what? It will be like IPv6, for example. Don't want to use that. I don't want to use Bluetooth. I don't want to use FFmpeg, which is maybe for multimedia encoding, decoding multimedia. Also for sound. Don't want to use sound on my VM, but this is also like all these stuff are optional. You can pick whatever you want and remove or just keep. Firmware, which is basically like the blobs, the drivers for like specific hardware, like NVIDIA graphics card or Wi-Fi cards, stuff like that. I don't want that, and we'll definitely remove FireWire, because FireWire is an attack surface that can be exploited. More specifically, DMA attacks, direct memory access attacks. Okay. So now that we have our plan, we know that the plan is to install, from the beginning, we know that we want to install a hardened version of Gentoo with SELinux on it. So it's always good to know what you need from the beginning, because that way you can by design secure your system, instead of going back and putting like bandage on it and trying to make it more secure. If you do it from the beginning, it will be much better. So we want to install anything that is particular for SELinux from the beginning. So for example, we want to install a stage 3 tarball that is particular for SELinux from the beginning. We will see that later. And because we know we want to use SELinux later, uh, if you look it up online and read the documentation, you will see that SELinux is not recommended to be used with the systemd init system. It is not stable, so they mask it in the profiles. That's why we know we want to use OpenRC instead of systemd. Okay, and the profile that we will be using will be hardened / SELinux, so we will be using that profile. Alright, so let's get started. Okay, so I will be installing I will be installing Gentoo on my VMware. I'm gonna go for the typical here, and then I already have the Gentoo ISO download, but if you don't have it downloaded, you can go to gentoo.org/downloads, and you will find it from here. It's the minimal installation CD. right here, gentoo.org/downloads. You can download it from there. Already have it right here, and you're not gonna find Gentoo anywhere here, but since we know we're gonna install a kernel that is 5.x, like later than 5.0, we're gonna pick this one. I'm just gonna name it Gentoo, and for the hard disk I'm gonna go for like 60 for now, single file. For the hardware I want 4 gigabytes of RAM, and I have like 4 cores on this computer, so I'm gonna choose like two processors, 2 sockets, and 2 cores per socket, and that will make it like a total of 4. And if you have more, it's better to always assign more, because that way you will save time later on when you are compiling with Gentoo. And yep, that's it. Alright, finish. There we go. Power on. Alright, here we need to be quick, press enter. The penguins on the top, they show you like how many cores you assigned to this VM. Oops. Key map US. Right, and now we're on our live CD. So the first thing we want to do is we want to start with the we want to start partitioning our hard disk. So for that, I'm going to use fdisk, the SDA, and I want to use P for print the partitions. You can see that obviously we don't have any. We didn't put any partitions yet, so we're gonna use N for new partition. I'm gonna go for default P, primary partition number 1, which is it will be our boot. First sector default, last sector we're gonna give this like 256 megabytes. Alright, done. Another partition, default 2, and this will be our swap, so we will give it 2 gigabytes. Should be enough. Oops. That's the first sector, sorry, my bad. And we're gonna give it 2 gigabytes. Alright, and a third partition, which will be our root partition. We're gonna give that all the rest. Right, now if we print our partitions, we will see we have dev SDA, dev SDA2, and dev SDA3. This is the size that we put for each one. Now for the type, Uh, for our boot, we want the type to be Linux, and for our root, we also want the type to be Linux. But for the swap, we want to change the type. So for that, I'm gonna type T for type, partition number 2, and if you know the alias or the hex code, you can simply just put it like swap or 82, and if you don't have it memorized, if you don't know it, you can just type L like they tell you to list them, and you will see down here on the bottom the alias for swap is 82 and the Linux it's 83. Okay, and so we're just gonna put 82. Now we have Linux swap. Linux. We're also gonna assign a boot flag on our boot partition. But for that, we're gonna put A and partition number 1. So bootable flag is now enabled on partition number 1. You can also press M and actually see the commands. So you can see that A is toggle a bootable flag. That's what we did. Alright, and now let's just enter partitions again just to make sure. Yep, we have the star right here, which means that this is like a bootable flag. It's a bootable partition. And our swap is also type swap, so we're good. And press W to write to disk, and there we go. All right. The next part would be to format our partitions. So let's go ahead and do that. We're gonna start with dev SDA1 or boot partition. So mk kfs ext 2 dev SDA1 done. Now for the swap partition, I'm gonna do make swap dev SDA2 and swap on dev SDA2. Now for the third partition, it's gonna be a bit different because we need to format this partition with Lux, because that way it will act like a container where we can put our, on top of it, our encrypted, we can format our file system on top of it. Okay, so for that we're gonna, this is the part where we use encrypt setup lux format dev SDA3. This will overwrite data. Oh, don't have any data, so yes in capital. Enter passphrase. So this is the passphrase that we'll need to put to unlock it every time. Just get this annoying thing out of the way. Passphrase will be Gentoo, just something simple for now. Verify it, Gentoo. Maybe later I can do another video to demonstrate how evil-made attacks work, like how can someone tamper with your init ramfs to gain access to your computer. Maybe we can demonstrate that. Could probably do another video. Sorry, can probably do another video to talk about how Lux work, how the encryption works, because it's really interesting. Alright, now that we have formatted our dev SDA3 with Lux, we're gonna open we're gonna open this partition and we're gonna map it. So looks open dev sa3 and we're gonna map it as just root. That's the label for it. Already it's gonna ask you for the passphrase that you just put. So we're just gonna type Gentoo. Alright, now just to verify, if you do ls dev mapper, you're gonna see root. Let's see if we do ls-l dev mapper. Okay, you can see it's kind of actually a link, and that's what the device mapper does. It takes like a block device and then it maps it as a high-level virtual device for you, which is what we can see here as root. And anything you write to this root, Lux will encrypt it and place it on the encrypted part, the actual encrypted part. So anything that goes in here will be encrypted in a transparent way, which means it's going to be encrypted on the fly. Like whenever you write something, it will instantly be encrypted on your hard disk. Okay, can probably do another video on that later, talk about this. Alright, so now it's time to actually put our file system to format with ext4. Alright, the mapper root, and that's it. So now we will mount the mapper root to mnt Gentoo. mnt Gentoo is where we will do our actual installation. And since this is like the slash, like the root partition, we're gonna mount it on our also on our root partition, on our like a root level on mnt Gentoo. So this will be like our root part. Okay, and let's cd into that. By the way, the $_ means like the last argument, since I mounted dev mapper root and the last argument was mnt Gentoo. If you cd into underscore $_ it will take this argument, so just cd into that. So now we want to download like the base system from Gentoo. This is what I was talking about before. We need the stage 3 archive, the tarball, and we want to try to install the hardened version of that tarball stage 3. So for that, like, since we don't have an actual browser on our TTY, we're gonna use a tool called links. First, let's do something we should have done like in the beginning. Let's try to see if we actually have internet access. Well, I don't. Oh, let me fix that and we'll continue. Okay, we're back. I fixed the issue. Now, just to double check, we actually have internet access. Alright, so as I was saying, we need to download the stage 3 tarball from the Gentoo website, and for that we're going to use a tool called links, gentoo.org, and that way we can just navigate on the website easily. And oops, so we have a stage 3 OpenRC here, which is kind of like the default, and we have a systemd version of it. But we want to go for like a customized stage 3 tarball. So we're gonna go here to stage 3 and gonna try to look for ours. There we go. That's the one. Oops, right on the top. Stage 3 uh, AMD64 hardened SELinux OpenRC. This is exactly what we need. I already have that downloaded. And then I also advise you to download the .digest for this file, because we want to do like a checksum just to verify that the file was not tampered with and it downloaded without any corruption. So we have like the good file. Alright, so I already have both downloaded. Press Q to quit. Have them both here. Yep. So if you look at the stage 3 digest, you're gonna see that it's actually just ASCII text. Okay. So if we less into this, you're gonna see that it just contains hashes and contains like a bunch of them. There's multiple checksums that you can do, but they're not actually the same. Like even though you have two 512 hash and SHA-512 hash here, if you look closely, you'll see that this one is for like contents, and this is what we need, the SHA-512 hash. I'm gonna use that one. So for that, I will have to comment out all the rest of them. Just gonna do place comments on them, and the command to check for the do the checksum is SHA-512 sum. It's -c. You can also verify that for the help. It says -c check read 512 sums from file and check them. Okay, so we also have our file in the same folder. So let's do that. Oops. Stage digest, and see that it actually checked the file, and the result is okay. So it's good. It's a good habit to do that every time you download something. If they provide like a digest, it's always good to do a checksum and verify your files. Alright, and so now we're just gonna extract this tarball with tar. The arguments that we'll provide will be X for extract, P for preserve permissions. We can do V for verbose, but let's not do that, and F for file, and then it's our file. And let's do that. And by the way, tar automatically detects like which algorithm was used with your tarball for compression. But you can also provide an additional argument here, because we know it was like XZ was used, so I think we can use like capital Z here in the tar. I'll look into that in the help menu just to be sure. Help. It's a big menu. Yeah, that's not good. Let's pipe that into less. Alright. Let's see. Maybe we can search for stuff. Is it? Okay, So it's actually hyphen capital J. Hyphen capital J right here. It says so for exit. Okay. Capital C is for compress, uncompress. It's not what we need. Okay, back to it. You can see we have our structure already laid out. All our structure is here. By now we can just probably remove any stage 3 stuff. Yes, yes. There we go. This is our structure. So let's continue. Now we want to mount dev SDA1, which is our boot. We want to mount that on our boot, as you can see right here. Okay, and now we're gonna prepare to chroot into the new directory. So for that, we're gonna set up the default repository for Gentoo, and we're gonna copy that from the live CD like that. So copy. Actually, we're just gonna copy that from our USR share location. Gentoo USR. Okay, first, we have to make the directory and the Gentoo etc portage conf repos.conf. There's our directory. And now we copy from the Gentoo USR share portage config repos.conf. Copy that into mnt Gentoo etc portage repos.conf. Repos.conf, sorry. Gentoo conf. So all we did is just copy our configuration for the repositories into this location, into our etc, which holds all the configuration, portage, and repos. So this is what we tell portage to go look like. We define what are the repositories for portage. Okay, and we're also gonna copy our resolve.conf, which actually has our name servers. There we go. The /d is for dereference. You can also look into that. Oh, there it is. /d. same as no dereference preserve links. So if it has any like links pointing to it, it will preserve it when we copy. So it will have like the same links. Okay. Next, what we're gonna do is we're gonna create the bindings between our live CD folders and the Gentoo install, which is like the place where we're gonna do the install. So let's go ahead and do that. Let's start with mount. Type will be proc. Let's start with proc, and it will be /proc. We will mount that on mnt Gentoo proc. Done. And now we will mount with rbind /sys to mnt Gentoo sys. Rbind just means that well, bind means that it will mount this location the same somewhere else, so right here. So whatever we put into whatever is mounted on the /sys, like in the subdirectories, will also be mounted here. Okay, so we have like two similar locations that look exactly the same. Okay, and then we're just gonna do like make mount mount that hyphen make r slave mnt Gentoo sys. So we'll tell it that this will be the slave, so whatever is mounted here or changed will also be done to this part right here, mnt Gentoo sys. Right, and we're gonna do the same thing for /dev mnt Gentoo dev. Also make r slave mnt Gentoo dev. And now we are ready to chroot into our new environment. mnt Gentoo. We can also do like dot, because we are in this directory, bin bash, and there we go. The way you can check like right now, way to check if we actually are in MNT inside MNT Gentoo or not. Some people just change their PS1, they export PS1 into something like chroot before live CD. Can do something else, like I usually just type echo shell level, and I'm in a subshell level 2, so that means I'm actually chrooted into MNT. Okay. Now we wanna source, let's see, profile, just to get like a new environment variables and everything for this. The new chroot. And we want to sync the repositories now, so the command to do that is emerge -web rsync. The next thing we're gonna do is we're gonna list all the profiles and see which one we're gonna go with. this is gonna take much more time, I'm just gonna pause the video and continue after it's done. I'll be pausing a lot throughout the tutorial because later on when we're gonna start like doing all the compiling and stuff, that's all just gonna take hours. Of course, it depends on how much resources you gave your VM. For me, generally, I find that sometimes compiling my kernel takes about 2.5 hours. So I would rather just pause the video and continue after the compilation is done. So you can see that the sync is finished. So let's continue. Let's list the profiles. So select profile list. You can see that's actually nice. So if you downloaded like the OpenRC regular stage 3 tarball, your default would be like this one, which is nothing. It's not nothing. It's just like the regular one without any additional stuff like the hardened or SELinux. But since we already downloaded the hardened SELinux stage 3 tarball, our default is actually 4. So we don't have to switch between profiles later, which is nice. That will save us less compilation for us. Okay, so let's see what's next. Okay, so now we're gonna go into our make.conf, and there oops, portage make.conf, and from there we're gonna put in some use flags to tell all our package manager like emerge that whenever we're installing something, make sure to keep the stuff that we're gonna specify here. Make sure to keep these stuff like out. Don't add any of that stuff into our installs. Or the opposite, which would be like install whatever we add here all the time, and you specify that with your use flags. So since we're using like full disk encryption, we want compatibility with crypt setup. So we want to enable that globally. So we want to enable crypt setup here, and as I said before, I don't want IPv6. I don't want to use it, so I'll remove it from here. So IPv6, and as a matter of fact, let's just remove anything else that we don't want that we specified earlier. So let's remove like Bluetooth. Let's remove firmware. Let's remove FF MPEG. Let's remove also just confirm. Yeah, also IPv6, Bluetooth, FM, firmware, FireWire. That will be removed. Like we're gonna remove that from the kernel. Okay, so no need to remove that here. Let's see, what else can we remove? Try to think. Yeah, so like smart card, you don't want that. You don't want sound. We don't want pulse audio. We don't want LDAP, cups for like printers. We don't want all that stuff. That's a good thing about Gentoo. You can control what you don't want. That's good. Make sure I have everything correctly set up here. Set up, yep. Okay. And since we're using VMware, let's go ahead and tell it that for video cards, I'm using VMware only, so it doesn't download like NVIDIA stuff. Something else that we need to add here is, I think it's accept license, and we put here star to accept everything. Let me just make sure. Yep. Accept license. There we go. So that's our make.conf. And yeah. Now what we're gonna do is we're gonna download the we're gonna do like a system update. Emerge update, and first it's always a good practice to use the pretend first, so it doesn't actually run it, it just pretends like it's running it, so it shows you what it's gonna do. New use deep world. Let's see. Oops. Okay, so this is because of the changes that we set. Just basically like add crypt setup, remove IPv6, remove IPv6, remove smart card. This is what we changed. Okay, let's do that. I'm gonna remove the pretend, and actually we don't want variables, we want quiet. Okay. And yeah, let's do that. Okay, I'm gonna pause the video and continue back when this is done. You can see it's gonna emerge 28 packages. Okay guys, we're back after setting our use flags and doing a system update. Now we're gonna take care of a few things such as the time zone, the locale. So let's go ahead and do that. So free ls usr share zone info. Let's see. Europe. Paris. Okay, so I'm gonna do Europe, Paris. So echo Europe, Paris into our, let's see, time zone. Then we're gonna emerge. So we're gonna reflect this configuration into our local time. So this is what it's gonna do. And this is /libs time zone -data. Okay, that's it. And next, we're gonna configure the locale. So let's go into the locale file. Let's see, locale.gen. Let's see, we have c.utf8, utf-8. We're gonna add some of our own. Let's add enus.utf-8, utf-8. Let's also add enus ISO 8859-1. Okay, locale-gen. Right, and then we're gonna select our locale. We select locale list. You can see we have a bunch of them. But what we want is number 6, which is enus.utf8. So we're gonna do select locale set 6. So it wants us to source Etsy profile so we can update the variable lang. Let's go ahead and do that. Source Etsy profile. So now maybe if we echo lang, it will reflect that. Yep. enus.utf8. Okay, that's good. So what are we gonna do next? We're actually gonna compile and install our kernel. For that, we're gonna do something like emerge. We're gonna use the ask first sys dash kernel Gentoo dash sources. Dash sources means that we want to compile from source. There is another way where you can download the binaries, but we're gonna go with that way. I'm gonna go with the Gentoo sources. Okay, let's see. Alright. So, just taking a look at this. So, yes. Forgot to use the a quiet argument with this, so it's just gonna print everything on the screen. Another way to make this go faster is you can just like switch to a different TTY, and that will help it go faster since it doesn't have to print anything on our TTY. So after we do that, we're gonna go into the kernel. Before compiling and installing it, we're gonna select stuff that we need for a crypt setup and loops for the encryption to work to make it compatible. Uh, Device mapper, stuff like that. And we're also gonna select the stuff for SELinux that we will need. Um, Make sure those are there too, and we're also gonna remove a couple of stuff like IPv6 and whatever we find that is not useful for us. Although the best way to do that is like if you're unsure about something, just don't remove it. Make sure you have a working system. Make sure you can boot into your environment and everything goes well. And then I would probably, after that, I would probably change some stuff, like remove stuff that I find are not useful. Okay. So let's see how this is doing. Probably gonna take some time. Okay, so meanwhile, let's just try to because I haven't explained what is SELinux yet. So let's just try to understand what is SELinux. SELinux is basically, it was created by the NSA, so they made SELinux, and SELinux is a mandatory access control in Linux. So by default, Linux has a discretionary access control, which means it goes by the owner or the group. So let's say if you are the owner of a file, you can do anything with it, right? So you can change the file, you can do anything, you can create file anywhere. But with SELinux, what it does is it adds labels to the files, which will be like a context on the sources. Okay, so with this context, for example, if you have a file in your home directory, it will have user underscore home context. If you try to move that into like a var .html, just trying to serve that in Apache or something, and when it sees that it has a context that is different, like what is this file doing here, it will not serve it. It will not work because it will check like hey, this is user home. This doesn't belong here. It wasn't created in this directory, so it will not serve it. And this is basically what SELinux does. It works on, it uses some like modules and rules to decide whether access should be granted or should be denied, instead of the very basic like per owner permissions, read, write, execute. So we're adding context. We're adding context into this. Right, this is our final one. So you can see here after each one it will say like unable to set SELinux security labels, that these are the labels I was talking about. That's normal because we don't have like SELinux configured yet, and we didn't even install the kernel for with SELinux enabled yet, so that's okay. Oh, by the way, since we're also we're installing Gentoo in a VM, there are some things that we need to enable in the kernel that are specific for like VMware, like the driver for the Ethernet VMXNet 3 and the stuff like that. We're gonna look into those later. Now it's finished, let's go ahead and make our kernel. There we go. Gentoo. Now the command to do that will be make menu config. And voila. Right. Let's see what kind of stuff that we need. So we need to enable support for initramfs first. Let's go ahead and do that. You can press I to look for it. So yeah, initramfs support is already enabled. We need to enable loadable module support. That's already enabled. We need in device drivers, we need multiple device drivers support, RAID and LVM. Multiple device driver support, RAID LVM. There we go. That's configured. We need device mapper support and crypt target support, and this is what I was talking about, the stuff to add so we can so it will support like the encryption and decryption of our root partition. So let's look for those. And device mapper support, that's already added. And crypt target support, yep, we need that, and we don't want it. So there's actually two ways to have drivers or anything in your kernel. You can set it to M for like a manual or module. Yeah, it's actually module. This means that we can load and unload this module into the kernel whenever we want. So it will not actually be built into the kernel. In contrast, like if we put a star, that means it will be built in with the kernel. So we won't be able to like unload and load this whenever we want. Okay. Next, we're gonna go into crypt target support, device mapper support. That's done. We're gonna go into file systems. File systems. Yep. And we're gonna so for SELinux we need to enable this. We need to enable extended attributes for all the file systems that we are using. So using ext2 and I'm also using ext4. There we go, these are already enabled. Let's see what else. I guess that's it. Oh, we need fuse support. Let's go back. No. Actually, don't see it. There we go. use file system in user space. Right, and then go back. We're gonna go into cryptographic API. We're gonna enable XCS support. We need that. And for the hash modes, we need SHA-224 and SHA-256 digest algorithms, which are already enabled. For the ciphers, we need ES cipher algorithms. Let's go ahead and enable ES cipher algorithms here too. And what else do we need? The compression, we need the user space interface for hash algorithms, and we need user space interface for symmetric key cipher algorithms. Okay, that's it for cryptographic API. Let's look into some of the VMware related stuff. So let's go into processor type and features. Here we're gonna need Linux guest support. Yep, and that's it. And also for our networking support, we'll go into networking options. We can remove stuff that we don't need, and but first let's add the VMware stuff. Virtual socket protocol, we need that. Virtual sockets monitoring interface and virtual sockets loopback transport, we need those. Let's see if we need something else. This should be it. For device drivers, let's go back into device drivers for VMware. We need to go into SELinux devices. We need VMware VMCI driver, and we need the VMware balloon driver. So for the balloon driver, I think what this does is if you have multiple VMs on your hypervisor, like here in VMware, if one of them is not using like all the allocated, let's say, memory that you have allocated to, and you have another VM that is like high on resources, it really needs resources, it can take, it can like borrow memory from another VM and allocate it to the one that needs it. So it will kind of like balance things out in terms of resources, which is nice. What else do we need in this? SCSI. Let's go back. SCSI device support. SCSI low-level drivers. Yep, it's in low-level drivers support. And here we have. There we go. VMware. back. We want Fusion NPT device support. Let's see. Yes, we want that. Let's go into I2C support and I2C hardware bus support. And we need Intel, this one. Tell it to put this as a module. Let's go back to network device support. It's actually here, device drivers, network device support. There we go. Here, full VMware PMX net 3. Yep, that was the Ethernet driver I was talking about. And for the graphics, I think it's down here at the bottom. Yep, graphics support. We need the DRM driver for VMware. Actually, it's not a module. And I think we missed something on in the networking support. Let's go back. Networking support, networking options. Yeah, VMware VMCI transport for virtual sockets. Definitely need that, because this one can only be a module. Okay. Now let's look into like SELinux stuff. I think it's here in security options. Yep, there we go. And I say SELinux support. There we go. So I think we only need this one. SELinux development support. Let's confirm that. Yep. So you can see I'm looking on the wiki. So of course, no one is expected to remember everything we need to add to our kernel. Well, that's why we have documentation. You can always go back and look at this. We only need the development support. We missed those two, so I'm gonna go ahead and add them. These are under security options. That's where we are. Enable different security models. Yep, it's already set, and we need socket and networking security to hooks. Yep, already enabled. And I think we're good. That's it. Let's see. Yeah, that's all we need. So save. Yep. Configuration is written. get out, and let's run it. So make modules, make modules, so install, and then oops, and then make install. Okay. This is the command to actually install the compile the kernel, the modules, install the modules, and install the kernel, and this will move it to /boot. Alright, let's go ahead and run that. Go. This is probably gonna take a while. This is gonna take a while, so I'm gonna go ahead and pause the video, and we'll come back when everything is compiled and set up. Okay. Okay, guys, we are back. We have compiled and installed our kernel. Let's take a look. Select kernel list. There we go. So let's select that. Select 1. Alright, you can see the stars set, so we're good. Now we're gonna actually build our initramfs, but we're gonna give it a flag Lux to tell it that we need to have our initramfs support Lux. So the command for that will be gen kernel -lux -install initramfs. Go. Oops. Oh yeah, we need to first. Yeah, that's my bad. First, we need to install gen kernel, and we're actually just gonna use gen kernel to build our initramfs. So let's install gen kernel. So just like we discussed before, our initramfs will have like the mechanism to ask us for the passphrase to decrypt the partition, our root partition. Okay. So after that, we're gonna configure our etc crypt tab and our etc fs tab. Then we're gonna build our grub. All right. Let's see how long this is gonna take. Okay, looks like this is gonna take a while, so gonna pause the video and we'll be back after it's done. Okay, we're back. So let's go ahead and install our initramfs kernel --lux install initramfs. Okay, while we're waiting for initramfs, let's go ahead and modify our oops, yeah, that's not, just need this one. Alright, and let's go ahead and put our partitions. The STA1, this is gonna be slash boot ext2 defaults no a time for no access time. It will not write access times on the hard disk, so this will make it a bit more faster. It will make it faster. And we have def mapper swap mounted nowhere, none. Label swap, file system swap, and then it's w 0 0, and then dev mapper root mounted on our root. It's gonna be ext4 no a time, and then it's gonna be 0 1. Okay, that's it for our fstab. Let's see how this is doing. Okay, still going. Let's take a look into our we don't have our crypt tab yet, so we're just gonna have to wait for initramfs to finish. Let's see. Yeah, let's just wait. Alright, I'm gonna pause the video and we'll be back after this is done. Okay guys, we're back and we finished installing our initramfs. Now we have to create a file here that's called crypt tab inside Etsy, and we're gonna add here swap dev sda2, and for the password, this is the field, the third field. This is where you put like where it's gonna get its password from, and we're gonna set it to /dev/u random. Go swap. So just finish that. And, we also finished doing fstab before. Yep, it's there. So next we will need to install our bootloader, which is grub. So before we do that, let's go into Etsy portage make.conf, because we want to tell it that we're gonna use we're not gonna use YAFI, we're just gonna use like BIOS. So here we'll say like grub platforms equal PC, grub platforms equal PC. Okay, next we're gonna emerge grub. Let's go. Okay guys, now that we have grub installed, we're gonna have to do a couple of changes into our grub. Let's see, default grub, and here we're just gonna have to add some parameters to the kernel command line. We're gonna do something like crypt root equal dev sda3, so it knows that this is the encrypted root partition, and we're also gonna add root equal dev mapper root. This is what we named it. Okay, that's the only thing we need to add here. Dev sda3 root dev mapper root. Okay, good. And now we install grub into our dev sda. Just do that. Okay. Done. Make config, and we're gonna make our config file to boot grub grub.c Okay, we're done with this. Now let's look into some more stuff that we can do. Yes, let's look into changing our hosting. let's see. Actually, let's see. So just conf.d hostname. Here, not gonna be localhost anymore. Just gonna be Gentoo. Okay, and let's see what else we need to add. Yeah, let's add networking, merge, no replace, net dash net ifrc. So this is for our networking. Yes, done. And it's different. W. We're gonna make it use DHCP by default. So here, let's see, conf.d. We're gonna say conf config 36. List one more right here. Yep, equal DHCP. This might not be true. Like the name of this interface might not remain the same when we reboot. It might change, so we will need to go back here and change this. Currently, ours is this. ENO 16 777736. This is what we have right now. Okay. And we want to start networking at boot. So in order to do that, we're gonna have to go into our init.d directory and make a symbolic link to net.eno. Actually, net.eno 16777736. Yep, and we're gonna do rc update add net dot em default. Done. So now our networking service will run on boot. Let's see. Yeah, we need to also configure our hosts file. So let's go into that and just let's change. Oops. Let's change localhost into Gentoo. Actually, we can keep localhost and then just add Gentoo here. Okay, and what else? Let's see. Well, let's add a user. So user add dash m dash g. I want to add that user to wheel, and login shell will be bin bash, and the username will be Dom. Okay. Let's just check. Yep, we got Dom over there. Let's give Dom a password. SWD Dom. New password. I'm just gonna put Gentoo at 123. Gentoo at 123. Done. What else do we need? Let's see. still need to configure SELinux. So let's look into that. Features equal hyphen dash SELinux. No, let's reboot. I think comes pre-configured when we install the tarball with the SELinux. So at this point, I think we're good to reboot. Yeah, we can probably just install some VMware tool stuff, but let's go ahead and give this a try. Gonna take a snapshot and reboot after that. So before we actually reboot, I just realized we never set a password for root, so let's go ahead and do that right now. This will also be like Gentoo at 123, Gentoo at 123. Alright, everything is set. Now we can reboot. Let's see. Is it because we are in... Yeah. Let's exit out of this and reboot. There we go. Okay. Let's see how this goes. Fingers crossed. Scrub. And okay, this is a good sign. And a TrumFS unpacking. Should be asking for a password. There we go. Gentoo. This is our passphrase to decrypt dev SDA3. Oops. Did I mistype that? Yeah, there we go. It's trying to grab an IP from DHCP. Yeah, got an IP. Let's log in, root, everything looks good. Gentoo at 123. There we go. Let's see. Yeah, there we go. This is the context that I was talking about. The sysadm underscore t, that's our label. Okay. Now, if we go to let's say slash home, let's go into Tom, for example. Okay, let's create a file here, just file.txt, and if we look to this, you can see, yeah, it's unlabeled. Probably need to relabel everything. Let's see. What do we need to do? I'm guessing we need to relabel the whole file system. Well, first let's check the configuration for SELinux. Let's see, SELinux. and config. Okay, so by default it's permissive. It means it's just gonna print a warning instead of actually enforcing the policies. It's better to have that in the beginning. Then we can probably change that into enforcing later, but this is better in the beginning just to go through, if we go through any issues, you can still work our way around it. And we also want a strict, which is full SELinux protection. The SELinux type means how it's going to handle the unconfined domains. Okay, so if something doesn't have like a module for it inside our file system, then this is how we decide like what are we gonna do with it. If it doesn't have a security module configured for it, then it will be in an unconfined domain. So if we have our SELinux type set to targeted, then that means we will permit anything that is in the unconfined domain. Whereas if we pick strict, it means if it's in an unconfined domain, then just deny it. Deny access for it. Doesn't have a security label, just by default deny access for it. Okay, so this is good. What else do we need to do? Let's try to go. Yeah, everything's unlabeled. We need to relabel everything. So let's go ahead and do that. So in order to do that, we're gonna create directory, gonna mount bind slash into mnt gentoo, and then set files dash r slash mnt gentoo at SELinux strict context files file contacts mnt gentoo, and then dev home proc run sys tmp. So this is how we're gonna apply our contacts into our file system. Okay, and go. Alright. Okay, that should be fine. Mount Gentoo manage. Actually, we're gonna rfpkg to relabel our file system. After that, we're probably gonna install i3. Okay, gonna pause the video and come back as usual. Okay, we're back. I just finished relabeling our file system, and now if we actually, like, we're in the home directory for Tom, if we do ls the -z, we're gonna see that now it says like user_home. This is created here. And if we do ls-z for like Etsy, you can see it has object r etsy_t, so it has the Etsy context in it, and it's the same for all our file system. You can see, like, if you go into dev, probably gonna do tty device. So everything is labeled. I'm gonna do another video to demonstrate like just dedicated for SELinux, but for now just wanted to install it. The last part of this video will be installing a desktop environment. So let's go ahead and install i3. Let's see. Oh, we never installed the VMware tools, so we need that to open VM tools. We need that. Well, you can already see like the downside of working with an operating system such as Gentoo. It's it's nice to compile everything and have this kind of freedom with the software, but at the same time it just takes forever to do anything. That's the downside. But I think like if you need to install it on just like on a server, and you don't need to keep updating and installing applications all the time, then it's fair enough. You won't be waiting that much time. It's not gonna be like everyday thing, and it's nice because you will have a very hardened server with no bloatware like at all. You can pick whatever you want and install in it, and that will be nice. Okay, I'm gonna obviously pause the video again, and we'll be back after we install OpenVM tools. Okay, so we have our VMware tools installed. Let's go ahead and start the service. VMware tools start. Gentoo 23. Done. And we want to add this into our init, so it will run at boot. VMware tools. Done. Added to run level default. Okay. So next we want to look into installing a desktop environment. And this is optional. For me, I will choose i3. I usually go for i3. So let's go ahead and install that. We need Xorg for the display server. We need the window manager i3. I usually install i3-gaps and i3 status, i3 log dmenu, and for our terminal emulator, I'm just gonna install extern. And let's also, let's see like how big this is. Pretend. Probably should have added verbose, but let's see what this is gonna give us. Yeah. Let's add verbose. Okay, so we also see something that says like the e-build selected satisfy blah 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 has unmet requirements. And then it says here the following required use flag constraints are unsatisfied. Exactly one of elognd systemd. So it's definitely not gonna be systemd. Probably gonna have to add a use flag here and set it to elognd. Let's see if that fixes this. Elognd. Okay. See. Okay. Alright, looks good. Let's go ahead and install everything. Quiet. And go. I think by now we should have like the full screen since we already have Humor tools installed. Let's see. I need to probably we need to reboot. That's okay. I think we have a problem here. All labels I could satisfy have been masked. Missing keyword, masked. Okay. I think we can solve this by adding auto unmask dash right. Let's see how it goes. Okay. I think we may need to install this with glvnd dash Gentoo. Okay, let me try to fix this and we'll come back. Okay, so looks like this is fixed. I just needed to do an etc dash update, and now we can see it's emerging all the packages that we need. It's a lot of packages, 122, so this is gonna take a lot of time. I'm gonna leave it run for a couple hours and we'll come back after this is done. Thank you. Okay guys, we are back and we have successfully installed i3. So to open a terminal in i3, it's mod and enter, mod plus enter. Uh, in my case, the mod is just the alt, so alt enter will open a terminal, and normally you will have like a very white background. I have added some changes to make it look like this. If you want to do these changes, you just have to put these changes in .x resources. You can see I have them here. Background black, foreground is green, and the border color is red, which is nice. Okay. Alright, so we're just gonna do like a small demonstration for SELinux, and first let's double check that SELinux is running. We can see that SELinux status is enabled. Our policy is strict and the mode is permissive. Okay, permissive means it will allow us to do everything, so it's not gonna deny us any access, but it will put like a warning in the audit.log if this action was prohibited. Like if we were denied access to something, it will just put a warning in the audit.log, but it will still allow us to perform like the action. Okay. So first, let's just take a look at the SELinux boolean. So se manage boolean less. Oops. Boolean. Okay. So these are like all the policies, like what we can enable and disable. Okay, for example, let's take this one, user underscore ping. It says control users use of ping and trace route. So if we use this, we can control whether users are able to use ping or not. Okay, I'm gonna set this to on. So set se user underscore ping to on. Let's double check. Alright, good. And now I'm gonna exit and I'm gonna log in with the lower privileged user, and we're gonna try to ping and see what goes into the logs. Alright, I've logged back in as user Tom, and we're just gonna ping 8.8.8.8. Alright. Now we want to go back to our root user and look at the audit logs and see what showed up. Okay, so we're back into our root user. Let's go ahead and look into the audit logs to see for any like logs that were created from that ping that the user Tom did. So there's a command to check for that. It's called au search. Okay, -m avc vc -ts recent, and we're gonna search for ping. And yes, exactly. We found out that there was a ping command that was initiated, and you can also see that it was initiated by user ID 1001, GID 1001. Okay, and like usually this would be denied, but it allowed it to happen because we're in permissive mode, but otherwise all those would have been like denied. Okay, and just to confirm, who is user ID 1001? ID Tom, and yes, of course, Tom is ID 1001. Okay guys, thank you for watching. I'll do another video soon just to talk more about SELinux, and I will do one more video to show how to perform an evil maid attack, where we tamper with with the init ramfs file. Okay, thank you guys so much.